Hello, everybody. So this is lesson 2 of our 5th unit on quadratics. Today we're going to be talking about solving quadratic functions, solving quadratic equations by graphing. Okay, so this is probably one of the easiest ways to go about solving a quadratic if it happens to have real solutions. So let's talk a little bit. So what does it mean to solve a quadratic function? What that means is you're basically needing to find the x-intercepts. Okay, that's what we're looking for when we're trying to solve by graphing. We're just looking at where do we cross the x-axis. Now remember, I could ask you to solve a quadratic function in various ways by asking you to find the x-intercepts. I could also ask you to find the zeros. I'm asking you the exact same thing. I could ask you to find the solutions. Again, I'm asking you the same thing. All right, and then I could also ask you to find the roots, and those all mean the same thing. So 3 different ways to ask. All right, so it's important to remember that all of these words represent the solutions of a quadratic function. So here's our steps for graphing. It's pretty simple. We're going to graph the equation. We're going to identify the number of real solutions, okay? And then we're going to identify the values of the solution, so just the x value only. So let's talk for a moment about identifying the number of real solutions. So we have 3 cases of what a quadratic could potentially look like. So I'm going to draw 3 separate x and y axes. Okay, and then I'm going to draw 3 different pictures. So here's my first picture. All right, here's my second picture. Oops, that wasn't a good picture. I'm going to try again. I had to touch the x-axis there is what I meant to do. So, okay. And then my last picture will be something like this. Okay, so these are 3 different scenarios that you can have when you're graphing a quadratic. Okay, and the middle one doesn't have to be upside down. I just chose to make it upside down. So the first example here, you should note that we have 2 real distinct solutions. Sorry that moved solutions. What I mean by distinct is that they're 2 different values, right? 2 definitely separate values. If you look at the second example, right, we only hit that x-axis one time. We just seem to kind of just graze it right there at that one point, that vertex point. All right, so we would say it has one real distinct root or one real distinct solution. All right, but the thing is, okay, we also know that this is called a double root. And we'll talk more about that when we get into our next few lessons for how we can solve it. Because to make this equation, you know, you're going to have 2 binomials to multiply to get to a quadratic. And so that's why this one is a double root. And again, we'll talk more about that in the future. And then the third example, we saw a few of these last class in lesson 1 when we were just graphing quadratics. This is an example of no real solutions. Okay, so although there's no real solutions, it's important to note that all quadratics have 2 solutions. So note all quadratics have 2 solutions, just some might not be real. So remember our last unit on imaginary numbers. All right, so let's go ahead and take a look at an example. So if you see this example here, it says to find the solutions for the quadratic function. Well, all that means is literally to look at the picture to see where we cross the x-axis. We cross at these 2 points. So my solutions are x equals -3 and x equals 1. Okay, it's just that simple. All right, so when we're solving by graphing, we're looking for nice numbers, essentially, a lot of the times. So then we did two practice problems in class together, but if you missed class, this is what the video is for. All right, so last class we talked about graphing quadratics, and I wanted to practice two more graphing problems. Now, last class we graphed by hand, and we are going to actually use Desmos today to help us graph. But before I head over to Desmos, just a quick reminder, this particular function that you see on your screen is in standard form. So when we want to find our vertex, which we definitely want to find our vertex, all right, we're going to do x equals negative b over 2a. If you look at your function, you'll notice that my b is already negative, so a negative negative 2 is going to become a positive 2. And then my a is negative as well, but 2 times negative 1/2 becomes just negative 1, and 2 divided by negative 1 is negative 2. Then we can plug that negative 2 into our function to find the y value. Again, we're going to use Desmos to help us with this in just a moment, but I just want to show you that you can still find it by hand. All right, so if we plugged in negative 2 into our x spot, well, negative 2 squared is going to be positive 4, but positive 4 times the negative 1/2 becomes negative 2. All right, negative 2 times negative 2 becomes positive 4. So we got negative 2 plus 4 minus 4. Negative 2 plus 4 is 2, and 2 minus 4 is negative 2. So our vertex is actually at negative 2, negative 2. Negative 2, negative 2, right there. So this is where we're going to use our friend Desmos. So just give me a moment here. I'm going to pull this over here. So what we're going to do is we're just going to type this function right into Desmos. So y equals negative 1/2. How did I get that to be a fraction? I literally just used the division symbol right here, or the backslash on your keyboard will work. And then x squared, so you can either put x and then hit this button right here, and it'll square it. Okay, minus 2x minus 4. So there's a picture of our graph right there in green. So what we would do to get a table, you hit this little button up here. When you hover over it, it says Edit List, and then you hit the table button, and you'll see we get a table of values. But remember, I want points on both sides of your vertex. This is only giving me points on the right-hand side. So if I want points on the left-hand side, I can just type in like negative 3. What's the value there? Negative 4. I could type in negative 100 and figure that out. Also, you should remember that your tables are symmetric. So if we make our table of values here, and again, I'm just using Desmos, so I'm going to put the vertex in the middle, and then, sorry that didn't stay in the middle, vertex in the middle. Then negative 3 and negative 4, and then negative 1 and 0 are my points that I'm going to use. And again, if Desmos doesn't show me that, I can just type right in. So if you take a look here, you'll notice that at negative 4, it's also negative 4, and that's what it's going to be at 0. At negative 3, it's negative 2.5, and that's what it's going to be at negative 1. All right, so negative 4, negative 4, negative 3, negative 2.5, negative 1, negative 2.5, 0, negative 4. There's my picture. All right, so although you might be like, what does this have to do with solving? Well, now I could say, okay, now that I have the graph, what are the solutions to the graph? Well, you would say there are no solutions because there's no x-intercepts. You should also still be able to tell me those important characteristics. So like my y-intercept, you should note, is right there at 0, negative 4. That's my y-intercept. You should also be able to tell me your domain, range, all that good stuff. So my domain for this one, my domain is negative infinity to positive infinity. My range, notice it goes all the way down forever and then comes up to this point. Remember, range is a set of y values, and so it's the only time we go from bottom to top. So it's negative infinity to negative 2 with a bracket. All right, if you look at this picture, you'll notice we are increasing on the right here, right? We're going up from left to right. So when do we start increasing? Well, this arrow is going all the way to the left. So we started increasing at negative infinity, and then we increase until we get to negative 2. And then we change direction and we start decreasing. So when did we start decreasing? At negative 2, and we decreased until positive infinity. Okay. And then our last example was in vertex form. So we don't have to do any math to find our vertex here. The vertex is just hk, which should be -1, -2. Remember, h is always the opposite of what you think. So -1, -2 is right there. We're going to go over to Desmos again. So if we head over to Desmos, I'm just going to literally click the X button here, and then we're just going to type in the problem. So it was y equals 2, am I typing that right? Yeah, 2x plus 1 squared, and then it was -2. So there is our picture. Okay, to get our table, again, we hit this button up here, and then we hit the table. All right, so we get the table. This time they did show us a point before our vertex and after, but we definitely want something before that because we like to get 5 points to kind of get a nice picture. All right, so we're just going to transfer the table over here. So -1, -2, right? Then we want -2, -3, 0, and 1. But we should remember that the tables are symmetric. So if I know at -2 my y value is 0, it's the same thing at 0, 0. And if I go back one more time to that table, I'll see that at +1, we have a y value of 6, so that's going to be the same for -3. So -3, +6, -2, 0, 0, 0, 1, +6. There's our nice skinny upward facing parabola. Okay, so now what are the solutions? Well, my solutions are x equals -2 and 0. Okay, my y-intercept is at 0, 0. My domain is still -infinity to +infinity. My range, note the very bottom is at -2, so I'm going to use a bracket, but then it goes upwards to +infinity. Now, when am I increasing? I'm increasing on the right half of this graph. When do I start increasing? I start increasing right here at -1, and I increase until +infinity. All right, now decreasing is on the left side this time. So we start decreasing at -infinity, and we decrease until we get to -1. And that's solving by graphing.